So we're going to get started. Thank you so much, everybody, for joining us. My name is Andrea. I work for the Fleet Science Center, and I have had the pleasure of doing so for the last 12 years. It's been quite a while. You're joining us, in case you're not quite sure, you're joining us for Sky Tonight, which is our astronomy talk, which we normally host at the beautiful Highcroft Dome Theater at the museum in Balboa Park. But due to COVID, we continue to be closed at this time. But that does not stop us from bringing science to you in the virtual format. Here we are, and we're still just as nerdy and excited about it as we are in the real world, right? Yes. Today I'm happy that Dr. Lisa Will, who is the Fleet's resident astronomer, is joining us again to lead us through the recent discoveries and news, the astronomy news in the world, and through the Sky Tonight. So she'll explain to us what we can see when we look up. I've got my window over there. When we look up in the sky tonight, and then she will also tell us all about meteor showers and comets. I'm very excited to learn more about that because I think November is a little bit of a meteor shower month. Yes. So just to give you a heads up, we'll let Lisa get through her presentation, but we will have a Q&A at the end. If you have a question though, and you don't want to forget it, feel free to type it into the Q&A section at any time. There should be somewhere in your control panel, you should see like 2 speech bubbles, and it says Q&A underneath it. You can just open it up, type in your question so you don't forget it, and I promise we'll get to it. And when we get started with the Q&A, I will launch a little audience survey that you can take while you listen to the questions and the answers that Lisa will give us to the fabulous questions that I know you will all be posing to Lisa. And I think that's all I have to share for now. If you missed the beginning presentation, my little slideshow, we do have fantastic events coming up virtually. We have Sky Tonight in December, which is
Galaxies,
right? And then January is the Wonder of Orion, and that was on my mind first. The Wonder of Orion is in January. But we also have science talks. If you like scientific presentations, or if you like chatting with scientists, we can also help you with that. We have our Sharp Minds lecture series on the first Monday of each month. So this coming Monday, we're going to talk to a deep sea researcher, and he's just gotten back from a trip. So it'll be exciting to see his latest photos and discoveries from the deep sea. And we have a program called Suds and Science. That's actually this Monday, sorry. That is more of a conversation with a scientist. So it's not your traditional lecture. There's not going to be any PowerPoint. But you get the chance to actually talk to scientists. We'll be in regular Zoom. We can all see each other. We can all interact with each other. And if you have kiddos or grandkids, there's tons of hands-on science fun and resources for you on the Fleet website. So if you need some science content for the kids or some entertainment for the kids, please make sure to visit the Fleet website, which is fleetscience.org, and you can find all sorts of wonderful stuff there. And with that, I'll leave it at that because we want to get to Lisa. So Lisa, why don't you take it away?
All right, let me get my screen shared here. All right. Thank you so much. As Andrea mentioned, I'm Dr. Lisa Will. I am the Fleet's resident astronomer. I'm also a professor of physics and astronomy at San Diego City College, and I'm happy to be here with you tonight to talk about some of the stuff going up in the sky. And so the first thing I want to talk to you about is the OSIRISRex spacecraft mission to the asteroid Bennu successfully carried out a sample return, or I shouldn't say sample return, a sampling of the asteroid on October 20th. What you're seeing here is a set of images taken over 3 hours as the spacecraft got closer and closer to the asteroid Bennu, and it actually made contact with the asteroid for about 6 seconds. And during that time, which we're getting up to right here, during that time, what the spacecraft did was it shot some nitrogen gas to kick up debris so that it could actually collect a sample. And it was extremely successful at collecting a sample. In fact, and now this is going to loop over again. In fact, the asteroid collected more sample than its sampling device could actually handle. So some of it got away, and then they were able to finally close the sample. So they had an overabundance of asteroid material. And that's in part because the asteroid Bennu turns out to be a little bit more rocky, and the soil seems to be a little bit more rubbly than was previously expected. And so, what you're taking a look at here, the asteroid itself is a small asteroid. In fact, this is the smallest solar system object that we've ever put a spacecraft into orbit around. And the spacecraft itself, if you imagine it being about the size of a van or an SUV, was hitting a target site called a Nightingale. And that was about the size of a small parking lot. Think of about like a handful of parking spaces to give you an idea. You'll notice you see a lot of rocks here. This is a very sharp and jagged asteroid. So they spent the first part of this mission just mapping the asteroid to look for a good place to try to take a sample from. And now that the sample collection has been successful, what will happen is the spacecraft will eventually fly back towards the Earth and eject the sampling container towards a region of the state of Utah for a sample so that the scientists can actually collect the samples. So this is an update of what happened on August 20th, or NASA's OSIRIS-REx spacecraft. And then I wanted to show you this set of images from the Bepi Colombo spacecraft, which is a European Space Agency mission to Mercury. But while on its way to the planet Mercury, the spacecraft is doing several flybys of objects to change its trajectory. So what you're seeing there is Venus. This is the spacecraft flying by Venus, and I don't know why, but it's just amazing, right? Because you see, you get part of the spacecraft itself in the frame, and Venus is just going by. It's like you or I are in the spacecraft ourselves, watching Venus go by. And so these are just a couple of current events going on in the solar system that you might be interested in. So now let's get on with a tour of the sky tonight. And so this is the sky set for tonight at around 8 p.m. So basically about the time that the show is over, so that if the sky is clear where you are, you can go outside and try to see if you can notice the same objects we talk about. To give you a sense of orientation, north is to the top, south is to the bottom, east is to the left, west is to the right. And so therefore the point directly overhead is pretty much right in the center of your screen. So when we think about what's up in the sky above us, the first thing that comes to mind tends to be constellations. And so here are the constellations in terms of their mythical representations. And it's always beautiful to look and see the mythical representations up in the sky like this. But when you or I go outside and we look up at the stars, we really just try to connect the dots. And so when I give you a tour of the sky tonight, I'm going to show you the stick figures because that's what your eyes are going to try to put together. So we're going to hit some of the highlights of the night sky. Starting off with a region of the sky that you are familiar with, and at least in terms of its names, these are the zodiac signs that are up in the sky tonight. And the zodiac signs gained importance. These are constellations that gained importance because not of what they are, but because of what travels through them. The zodiac signs are the constellations that the sun travels through. So the green line that I've just put up with the here with the names of the months next to it is the ecliptic. That is the apparent path of the sun on the sky. And what you're seeing there is where the sun is on any particular given day of the year. So because we are in the beginning of November and I have the sky set for 8 o'clock, and now here in San Diego, the sun is actually setting around 5. I think when I looked today, it was supposed to be like at 4:57 or something like that was sunset. So the month of November is well below the western horizon by 8 o'clock because the sun is well below the western horizon by 8 o'clock. So these constellations gained cultural significance because they are the constellations that the sun travels through. But not just the sun, the moon also hangs out over there. So later tonight, the moon will rise. It'll actually start rising not long after we get out of this show, but it's not up exactly at 8 o'clock here. So the moon follows along the ecliptic, and so do the planets. And so here we have the ecliptic without the zodiac signs on it, but I want to highlight the planets that are up tonight. So there are 3 planets visible to the naked eye tonight when you go outside. Over in the western part of the sky, setting in the constellation Sagittarius, are Jupiter and Saturn. And then almost directly above you when you go outside tonight at after the show, there is a bright red dot above you in the sky, and that's Mars up in the constellation Pisces. So let's take a look at some perspectives of Jupiter and Saturn and Mars. So this is an image by an astrophotographer named Georgia Hofer, which was a recent astronomy picture of the day. And these are the photographer and her partner looking at Jupiter and Saturn setting over the Alps, actually. So Jupiter is the bigger, brighter dot, and Saturn is the bright dot next to it. And if you've been watching Jupiter and Saturn over the summer, you'll notice that they were getting closer and closer together in the sky. And in fact, in mid-December, there something called a conjunction will happen. A conjunction is when basically conjunction conjoined, together. What in astronomy is called a conjunction is when 2 objects get really close to each other on the sky. Not really close to each other in space. They're nowhere near each other in space. But on the sky, from our point of view, they're going to be really, really, really close to each other. In fact, they'll be closer to each other than what the full moon looks like on the sky. So they're going to be really close to each other. And so they have not been that close to each other since the 1600s, and they won't be that close to each other again till towards the end of the 21st century. So this will be quite something to see in mid-December. And so this is a lovely image showing how close Jupiter and Saturn are in the sky. And then I wanted to flip our perspective a little. This is a set of Cassini images of Saturn's rings, processed by Kevin Gill, who is an amazing, amazing astrophotographer. Now, what he did was he took this Cassini data on a particular day. You see those 2 dots here in the midst of Saturn's rings? That's actually the Earth and the Moon, as seen through the rings of Saturn from the Cassini spacecraft. So I just thought, since we were just looking at Jupiter and Saturn here from Earth, let's take a look back at Earth from Saturn. And so the sun was temporarily blocked by the ball of Saturn in this case. And so you could actually make out the really faint Earth and Moon in this image, just little tiny points of light over 1 billion kilometers away at the time. And also, I love this because you can see the structure in Saturn's rings. And the brighter regions of Saturn's rings where there's actually more ring particles, so it can reflect more sunlight. The darker regions are called gaps. Some of them are true gaps where there aren't any ring particles, and some of them there's just fewer particles to reflect light, so they're just fainter. So yeah, that's the Earth and Moon as seen from Saturn. And so Jupiter and Saturn are setting in the west tonight over in the constellation Sagittarius. And then up above us in Pisces is the planet Mars. And Mars has been glowing beautiful and red in the sky. And this is an image by another brilliant astrophotographer named Damian Peach, and he posted this on his Twitter feed. And this is a set of images, stacked images of Mars that he took just a few days ago. And this is just amazing, right? What I love about this is that you can see that Mars has an atmosphere. It's not a very thick one, but Mars does have an atmosphere because those things that look sort of like wispy clouds are actually wispy clouds. And Mars does have ice caps, and you're seeing one of them there. And then the thing that looks kind of like a jagged line across the middle is uh, Valles Marineris, Mariner Valley, which is the largest canyon in the solar system. It's basically a Grand Canyon, the diameter of our United States. And those things that look like bumps over on the right are actually some of the volcanoes over in the Tharsis region of Mars, kind of poking up through the clouds. And so some beautiful images of Mars, Jupiter, and Saturn, which are above us up in the sky tonight. So now let's take a tour of some of the constellations up in the nighttime sky. So we have Capricornus, one of the signs of the zodiac. It's the second faintest of all zodiac signs, so it's really, really faint. This is one of those regions of the sky that we wouldn't notice if the planets and the sun didn't travel through there to catch our attention. In a bright metropolitan area like San Diego, only really the bright star at the tail of the sea goat, which is what Capricornus is, can be seen. It's a star named Deneb Algety. It's about 39 light years from our solar system. A light year is a distance that light travels in a year. So if you were to go outside tonight and find Deneb Algety and it's 39 light years away, you wouldn't be seeing it as it is. You would be seeing it as it was 39 years ago, because that's how long the light took to travel to us. The next sign of the zodiac over to the east is Aquarius, which means the water carrier or cup carrier. And once again, this is a case where, even though if you take a look at it here on this map of the sky, it looks big, and it is big, but you'll notice all the little dots that we're connecting with those lines there are pretty faint. It has no particularly bright stars. Um, and this region of the sky has been associated with water for a long time. In ancient Egyptian astronomy, Aquarius was associated with the flooding of the Nile, where the idea was that the banks of the Nile would flood when Aquarius put his jar into the water. And that would mark the beginning of spring, because if it's up in the sky at night in fall, that means it's up during the day in spring. That's where the sun would be in spring. The next sign of the zodiac to take a look at is Pisces, the fish. In fact, the location of where the sun is on the spring equinox is in Pisces. And this is, again, yet another fairly faint constellation. The bright red dot that's under the eye is actually Mars, right? Which isn't a permanent member of Pisces. The brightest star in Pisces is actually the little dot connecting the V there, which is a star named Alresha, about 139 light years from our solar system. Now, Pisces isn't actually, so Pisces represents two fish, usually tied together with a cord. But it's not the only fish up on the sky. To the south of Pisces is a fish called Pisces Australis, which is the southern fish. And it is a relatively small and faint constellation, but it has a bright star in it named Fomalhaut, whose name comes from an Arabic term that means the mouth of the southern fish. And this is a bright star located about 25 light years from us. And so when you go outside and you're looking, if you want to look for the star Fomalhaut, you want to look more level towards the south, not up high, but more level towards the south. This is a bright star low on the southern horizon. And it's one of the brighter stars that you can see over in that direction. And although you may not have heard of this constellation before, it was one of the 48 constellations cataloged by the Greek astronomer Ptolemy in the 2nd century. And a lot of constellations, a lot of the 88 constellations that professional astronomers still use today, a lot of them started off in that catalog. So you might be wondering what is this myth for this particular fish? This constellation has its origins in Babylonian culture, and it's associated with the myth of a particular Syrian fertility goddess who fell into a lake near the river Euphrates and was rescued by a large fish. So this would be that large fish from that myth. Not the only water living creature here. Still, we have another one, Cetus. Cetus is either referred to as a whale up on the sky, but more commonly a sea monster. And so you'll see it depicted both ways. The most interesting star in the constellation Cetus is the star Mira, which is a variable star. And by variable star, we mean it varies in its brightness with a regular repeating fashion. And it was one of the first of that particular type of star that was ever discovered. Its brightest star is called Minkar, and it's about 200 light years from our solar system. Now, if it's a sea monster, and we talk about sea monsters being part of myths, well, what myth is this sea monster from? Well, it is thought that Cetus, the sea monster, is referring to the myth of Andromeda. And Andromeda is also a constellation up in the northern part of the sky. And Andromeda was a princess who was captured by a sea monster. And she was then saved by Perseus, who was a hero in Greek mythology. known for slaying the Gorgon Medusa by cutting off her head. And so lots of times when you take a look at the mythological representations of the constellation Perseus, it's actually carrying a head of snakes, because Medusa the Gorgon is the creature that had the head of snakes. And the most interesting star up in the constellation Perseus is yet another variable star called Algol, which comes from an Arabic term called Ras Al Ghul, which means head of the ogre, or is often referred to as the demon star because it was noticed to flicker and to change. And this one's actually a variable star because it's not one star, it's two. It's an eclipsing binary. And so as one star gets in front of the other one, sometimes you see both brightnesses and sometimes you only see one. So you see this repeating pattern in its change in brightness. And it's about 90 light years from our solar system. All right. So what have we had here so far? Perseus saved Andromeda from the sea monster. Why did the sea monster have Andromeda anyway? Well, her mother was Cassiopeia and her father was Cepheus, and they were a king and a queen that were so proud of the beauty of their daughter that they boasted that she was even more beautiful than the gods, the children of the gods, and that irritated the gods. And so this myth is that Andromeda got punished because of her parents, and then she was rescued by Perseus. So I'm not quite sure what that's trying to say, but I did want to point that out because a lot of the times, and I say this at the Sky Tonight regularly, a lot of people associate constellations with stories, and that's true. But we usually think of each constellation telling sort of a whole story in and of itself. But a lot of the times, constellations are connected in their stories across the sky. And in this case, this is a connected story that takes up a huge part of the sky. I wanted to point out Cassiopeia again, though, because it is a fairly bright constellation up towards the northern part of the sky. And it has 5 bright stars that make a prominent M or W on the sky. And so it's usually pretty easy to pick out if you have a clear view of the northern sky. Cepheus, not as much fainter stars. Another mythological creature up here that's actually still even kind of associated with this myth is Pegasus the winged horse. And the way that Pegasus comes into this is because when Perseus slew the Gorgon and cut off her head, the winged horse Pegasus sprang from her body. And so another part of the Perseus myth here. And if you wanted to go outside tonight and look for Pegasus, you'll notice at about 8 o'clock tonight, this is almost directly above us. And you'll see that thing that looks like a big square. This is often referred to as the Great Square in Pegasus. It is a big square above us of 4 prominent, uh, decently bright stars up in the sky. And it even looks more square on the sky than it does here in this image. And so if you have a clear sky tonight, go outside and take a look for the big square. Excuse me, the Great Square. So, what other constellations are up here in the sky tonight? We have Aquila, the eagle. It's thought to represent the eagles who carry Zeus's or Jupiter's, depending on if you're talking the Greek or Roman myth, uh, carrying the thunderbolts. And so it's a weird thing of thinking of eagles of carrying thunderbolts, but that's what it's up there doing. The brightest star in Aquila is named Altair. It's a close star to our solar system. It's only about 17 light years away. So if you go outside tonight and take a look at Altair, you'll see it as it was 17 years ago, not as it is tonight. Also brightly over in the western part of the sky is the constellation Cygnus, which is the swan. And the brightest star in the constellation Cygnus is named Deneb. Right now, it'd be pretty much under the G in this image, where the font put the name. And it is actually a bright star comparable in brightness to Altair down in Aquila. And Deneb marks the tail of the swan. And it is as bright as Altair, although it's much further away. It's actually about 3,000 light years away. So if you go outside tonight and look at it, you're not seeing it as it is, but rather as it was about 3,000 years ago. So I like to use this as an example that even though those stars might look the same brightness to us up in the sky, we don't have good depth perception on the sky because not all stars emit the same amount of light. And so we can't just say, oh, the fainter the star is, the further it is away, because that lets us down. In fact, a lot of the stars closest to our solar system are so faint we don't see them with the naked eye. And yet we can see ones that are much further away. And then there's one other bright star I want to point out to you over in the western part of the sky, and that is Vega up in the constellation Lyra. Lyra represents the harp of Orpheus from Greek mythology, and the star Vega is named after a phrase that means swooping eagle, so kind of keeping with the bird theme over in this part of the sky. Uh, Vega is the fifth brightest star in the Earth's nighttime sky. It's about 25 light years from our solar system, and it shines a bright white up in the sky. And these three stars, close together up in the sky, although not close to each other in reality, they make up something that's called the summer triangle. So you may have noticed this big triangle not far from a great square up in the sky. This has been, it's called the summer triangle because it's more prominent in the summertime, but it's been prominent in the early evening sky this fall. And this is about your last chance really for seeing it before the winter constellations take over. So go try to take a look for the summer triangle before it disappears until next summer. Let's get back to a few more of the zodiac constellations. We have Aries, the ram, which is up in the sky. Now, this is one of those constellations that I have a hard time finding up in the sky because it's really only like two bright dots that you can see from a city. Its brightest star is named Hamal, and it's about 66 light years from our solar system. Aries is a very faint constellation of the zodiac, but the next one over is Taurus the bull, and that's actually one of the brighter, more interesting signs of the zodiac. The bright red star marking the eye of the bull up above or near the constellation or near the T in the constellation name, that is Aldebaran. It is an example of what we call a red giant star. So it's a star that's evolving and has already spent its nuclear fuel, the hydrogen, the helium in its core, and it's now burning other nuclear elements or doing other nuclear processes on its way to finally ending its life as a star. It's located about 65 light years from our solar system, and it's part of the V that makes up the face of the bull in the constellation Taurus. But all the other stars in that V, they don't even know Aldebaran exists because they're not actually all part of the same cluster. But the other stars in the V are part of a cluster of stars called the Hyades, which is an example of an open cluster of stars, stars that were all born together out of the same cloud of gas and dust. And so that's just a quick tour of what's up in the sky tonight. So hopefully the weather will cooperate and you'll have a chance to go outside and take a look for what's up in the sky. Now, what isn't up in the sky right now, visible to the naked eye, are any comets. But we did get lucky earlier this summer and had a naked eye comet that we could see from here in San Diego. So I'll show you a couple pictures of that one. But you might be wondering, what is a comet to begin with? Well, comets are relatively small icy objects that orbit the sun. And what I mean by relatively small is that they're too small to be considered a planet. The icy solid part of them is usually only like we can measure it on order of kilometers in size, not thousands of kilometers, but dozen kilometers or so. They have highly eccentric orbits. And what I mean by that is that their orbits take them much closer to the sun at some parts of their orbit and then much further away. And they tend to come from a few places in our solar system. There are a couple of comets that are called maybe sort of Jupiter family comets that have really short periods around the sun, only about every 20 years or so, like the comet Encke. But we also have the short period comets that come from the Kuiper belt here. And what you're seeing is for the Kuiper belt, it is like a donut of comets, of icy objects that orbit the sun. And it starts out at about the orbit of Neptune. And so some of the smaller objects have really eccentric orbits that bring them significantly closer to the sun at some parts of their orbits. And the icy part heats up and starts to form a tail. And that's when we notice them as comets. Not all of the objects out in the Kuiper belt come close to the sun during their orbits, like Pluto, which is out there in the Kuiper belt. And then and so comets that are out there, they can have orbits that take them about 200 years, like or less. Like Halley's Comet is considered to be a short period comet that we see coming in from the Kuiper belt. Now, we also have what we call long period comets that emanate from the Oort cloud, which is the spherical region of icy objects that surrounds our solar system. And they can take thousands to millions of years to orbit the sun once. And we can tell that from the shape of their orbit as they come in. So we can actually just look at their orbital components as they orbit the sun and then predict the rest of their orbit, the shape of their orbit and the period of their orbit. So, when comets get really close to the sun and get close to the earth, we can get really fun images like this up in the sky. And so I can see in the Q&A a question that's completely relevant to what we're talking about right now. So thank you for that. And the question is, what are comets made out of? Well, astronomers often refer to them as dirty snowballs. The idea being is that they are mostly made out of ices like water ice and carbon dioxide ice and carbon monoxide ice, just things that we would normally see as liquids or gases here on Earth are solid at the cold temperatures way out in space. But we do see some dusty components as well, materials made out of carbon, silicates, and so on. And as the comet gets close to the sun, it heats up, but because there's no pressure out in space, I guess we could say no atmospheric pressure because there's no atmosphere. Instead of melting, it goes from the ice to vapor, which is called sublimation. So as the comet heats up, the ices start to go into the gas phase, and some of the dust comes off. And then the charged particles, or ions, start to interact with the sun's magnetic field. So as the comet orbits the sun, the ion tail always points directly away from the sun, but the dust tail will curve trying to follow the comet's orbit itself. And then there also usually is a color difference where the ion tail often takes on sort of a bluish color in images. So this is actually that comet that was prominent up over the summer of 2020, Comet Neowise. This is an image of its dust tail, which is the wispiness off to the right of the image, and its ion tail pointing away from the sun along the sun's magnetic field lines, looking more bluish. And so this would actually be a true color image of it. Some comets start to show sort of a more greenish uh, if, uh, appearance due to a process called fluorescence. So some of the electronic properties of the particles responding to the sun's light here. And so this is Comet Lulin from back in winter of 2009. And you might notice to the left of the fuzzy green ball of the comet, you might see a couple of other fuzzy disks looking things, and those are galaxies. Uh, we actually, some of you, if you're interested in astronomy, you might notice that there's lots of objects that have M's in front of them, like M57, M101. That refers to the Messier catalog made by Charles Messier. And he was cataloging fuzzy objects up in the sky because he wanted to hunt comets. And so he wanted to know where the fuzzy objects were permanently. So the ones that just appeared every now and then, he could identify them more easily. Because this was actually one of the interesting questions about comets, because they can get big up in the sky. And so for a while, it was thought that maybe these were actually atmospheric phenomenon, that these fuzzy blobs in the sky were actually part of our Earth's atmosphere, like a cloud. It was actually Edmund Halley who said that due to an appearance of a constellation in stories, or excuse me, of a comet that showed up in stories with the same period, like every about 70 to 80 years, he predicted, I think this is an astronomical phenomenon and it will appear again 70, 80 years after its last appearance. And that actually actually is how that comet became known as Halley's Comet. He did not discover it. He was the first to figure out what it was. Nowadays, comets actually are named after the people or the projects who discover them, which is how these names come about. So this is what a comet looks like up close. This is actually Comet Wild 2 as seen from the Stardust spacecraft, which was actually another one of these sample return missions where the spacecraft actually got very close to the comet, stuck out a pack of aerogel. Cometary particles flew into it and then it ejected back towards the Earth. So this was one of our first sample return missions. And cometary nuclei are composed of rock and dust and water ice and ammonia ice and carbon dioxide ice. And like I said, there's all these things that we normally think of as being gases on the Earth are frozen solid out in space. I said that they are often referred to as dirty snowballs. That also depends on the ratio of ice to rock. So some say they're icy dirt balls. It all depends on which particular comet that you're talking about and where it is in the solar system and where it came from. This is another comet that was visited by spacecraft. This is Comet 103P, or known as Comet Hartley 2, that was seen by a NASA spacecraft that flew by it really, really, really quick. This was actually taken from about 700 kilometers away. But perhaps the most successful and well-known comet mission was the Rosetta spacecraft. And here it is kind of taking a selfie of its solar panels. And then that thing up at the top is actually the comet itself. And what was very interesting about this mission, which was a European Space Agency mission, is that it was the first spacecraft to catch up to a comet and then fly along with it. It didn't go into orbit, but it flew along with it as the comet got closer and closer to the sun. So we could see the jets of material, we could see the gases and the ices and the dusty parts actually coming off the comet as it got closer to the sun. And so this is what this particular cometary nucleus is what we call it, looks like up close. And like I said, this is several kilometers across. And what was particularly interesting about this one is that it looks like two things ran into each other, and you'll see where the two, if you imagine those are two spheres that ran into each other, you can actually see the smoother part where they joined, like the heat from the collision caused that material to heat up and kind of melt and solidify a bit as it came back together. For those of you who might remember a couple years ago when the New Horizons spacecraft passed by MU-69 out in the Kuiper Belt, it also looked like two objects that had collided, two icy objects that had collided and formed this sort of peanut, or in that case, snow person type shape. So this might be evidence that collisions of these icy objects happened more often than we thought. This is another perspective of that cometary nucleus from the Rosetta spacecraft. And I just kind of love it because you're seeing a perspective now. You're not seeing it from a distance. You're seeing things that look like cliffs and rocks and so on. This now looks like a place and not just a fuzzy blob up in the sky. And then the Rosetta spacecraft mission came to an end. And this is from a very close up image of it because they basically crash landed this spacecraft onto the comet as it came to end of mission so that you can get some data during its descent. But I wanted to show you perhaps my favorite data from the Rosetta spacecraft, which is this set of 25 minutes worth of images. And doesn't it look like it's snowing? And in many ways, it kind of is. There are three things going on in this. There are stars in the background that are moving because the spacecraft itself is moving. So the things that are moving straight down, those are stars in the background. There are some things that we call cosmic rays, which are high energy particles just hitting the digital camera itself. But the stuff that looks like it's swirling actually are cometary particles. So you actually are seeing something that's almost like snow coming off of this comet. So I bet for a lot of you, I bet this is a lot closer up to a comet than you thought we've seen before. But I like showing you this because we do see material coming off of comets. And that material coming off of comets happens more when it's close to the sun. And so it tends to happen at very specific parts of that comet's orbit. And then when the Earth crosses those bits, that's when we're going to get meteor showers. But sometimes when a comet gets close to the sun, it doesn't make it back out intact. So the object in the middle, these are extreme ultraviolet images from the SOHO spacecraft of the sun. So the object in the middle is actually the sun. And the thing that you see getting closer to it and then further away, that was Comet Ison from back in 2013. That was the comet that was prominent up in the sky around Thanksgiving. And everyone was really excited because if it survived going around the sun, then on its way back, it was going to be close to the Earth at the same time. And so it would have looked really, really great in the sky. And the sun didn't want any part of that. The sun just said nope, and pretty much disrupted the comet. You can see how much smaller and fainter it gets. It basically came apart. And we do see that. This is a Hubble Space Telescope image of a particular comet known as Schwarzmann-Watchman 3. And once again, it's a case as it's getting closer to the sun's heating it up, causing sublimation, and sometimes the ice comes off in chunks, not just going to vapor through its interaction with the sun. So cometary orbits tend to be littered with debris more times, but because it does happen at particular points in their orbit when they're closest to the sun, this debris can be kind of chunky in the orbits. And so because the Earth goes around the sun once a year, we tend to pass through the orbits of comets on a yearly basis, which is how we can predict meteor showers. So, for example, here imagine we have a orbit of a comet coming in from above the plane of the Earth's orbit around the sun, which we can get from the long period comets out in the Oort cloud. And so you'll see places in its orbit where there is more debris than others. And so when we pass through that part of the orbit, though, we get hit by these tiny little bits of ice and dust, causing these streaks of light that go across the sky, which we call meteors. This is an XKCD thing predicting when certain meteor showers happen. And a lot of these are actually real meteor showers. Some of these are made up, but a lot of them are real meteor showers. And I wanted to show this to you because, like the Perseids on August 12th, the Perseid meteor shower happens around August 12th every year. We have the Leonids coming up here in mid November. They happen. They happen every year. But you'll notice in this one, it said there was an unusually active one in 1966. I'll mention a reason about that, although it probably didn't kill God, but likely a NASA hoax because that one tends to happen during the day. So you might be wondering, what are these things and how can we predict when they happen? Well, let's go to a more formal graphic, say from a textbook. And so, this comes from an Astronomy 101 textbook that I often use when I teach classes. And you'll see the name of the meteor shower, the rough hourly count, and what's called the parent object for that particular meteor shower. So, a meteor shower is when you have a lot of meteors in an hour. If you and I were to go outside on any given night of the year and just watch the sky for an hour, we'd likely see at least one meteor. And so a good rule of thumb is that a meteor shower is like 10 or more meteors per hour in the sky that you can depend upon going to happen. The name of a meteor shower comes from the constellation where it looks like it's emanating from, because as we travel around the sun once a year, we hit the orbit of that comet from the same angle at the same time every year. So the Geminids in December look like they're coming from the constellation Gemini. The Orionids in October look like they're coming at us from the constellation Orion. And then the Leonids, which are coming up here in mid-November, you'll notice that it says 12, uh, roughly you can expect about 12 meteors per hour, but there's an asterisk. And it says every 33 years, the Earth passes through the densest part of this orbit is kind of really chunky. Every 33 years, we go through a particularly chunky part of this orbit. And it produces what we call a meteor storm, where you can see hundreds to thousands of meteors per minute up in the sky for really, really brief times. So the last time that happened was in 1999, and I remember going outside and taking a look at that, and that would look like fireworks were going on across the sky. So, like I said, we understand what cause meteor showers because science allows us to do so. We know that this happens because we're crossing the orbit of a comet. We orbit the sun once a year. We cross the orbit of a comet at the same point every year. So we can predict when and where in the sky these meteor showers are going to happen. So, for example, a really prominent one is the Perseid meteor shower that happens every year around the 11th, 12th of August. And this one is usually a reliable meteor shower, I like to say, because August also tends to have good weather and it tends to produce a lot of bright meteors per hour. And so you can see here the way the meteors appear to be streaking from, it looks like they're coming out of the constellation Perseus. It's something we call the radiant. And so, if you were to be looking up in the sky, this is a set of images through a webcam of what meteors look like up in the sky. Little bits of ice and dust burning up in the atmosphere on their way down towards us. Meteor showers are great because you don't really need any special equipment. You'll see more if you're actually just looking up at the sky with your eyes than with the narrower field of view of binoculars or a telescope. The just having a nice dark sky and knowing what direction to look at, it gives you a great view of meteor showers. So the Leonids, named because they look like they're coming at us from the constellation Leo, are going to peak this year on November 17th before dawn. Their comet of origin is Comet Temple Tuttle, and every year we see them happening. And like I said, about once every 33 years, we see a meteor storm associated with these, but there's still a pretty decent meteor shower. You can usually rely on about 15 meteors per hour. Um, the one thing that can actually interfere from our point of view is whether or not the moon is up and is bright and is interfering with our ability to see the fainter ones. But these will be more easily visible before dawn. I think the peak time is around 3 a.m. and the moon will have set by that time. So this year, if we have good weather, the Leonids should look pretty good. So what you just need is a good view of the eastern sky. You don't need to necessarily focus on Leo, but the streaks will be going across the sky looking like they're coming at us from Leo. So this is a set of images of the Leonids streaking through the constellation Canis Major in a long duration image. So you can see what the streaks look like across the sky. And you can tell that they're all coming from one direction, which is why it looks like a shower, right? It looks like there's that almost looks like raindrops at an angle. And this is what the Leonids look like from space. This is a set of images taken from a Defense Department satellite, if I recall correctly. And I like to show this because it shows you how high up the little bits of ice and dust are burning up in the sky. Those streaks that you see are due to these particles heating up the atmosphere and cause the air around them and causing it to glow. So these meteors, the little bits of ice and dust that burn up during these meteor showers, we're not worried about going outside and getting pelted by debris during a meteor shower. These particles actually burn up really, really high. And if they do make it deeper in the atmosphere, or if they are bigger chunks, you get to see them get bigger and bigger. But not many what we call fireballs tend to be associated with meteor showers. Those are usually actually due to bigger chunks of rock making it through the atmosphere and landing, and then we call those meteorites. And those are awesome, but we don't tend to find meteorites associated with meteor showers. So that's comets and their relationship with meteor showers. I just wanted to show you a few more pretty images, and then hopefully you'll have some more questions for me. This is an image of Comet McNaught taken in 2007 when it was prominent up in the sky in the southern hemisphere. This is an image taken by an astrophotographer named Druckmiller, who was in the Patagonia region. And you can actually see the Milky Way and the small and the large Magellanic clouds in this image. And then this is Comet Lovejoy as seen from the International Space Station several years ago. So that streak that you're seeing across the lower part of the image is actually the Earth's atmosphere. And then one of my favorite images of Comet Neowise this past summer. This is by Matthew Brown, who is a Welsh photographer who got this beautiful image taken over Stonehenge. And so that's just a quick tour of meteor showers and the sky and comets. So I will happily take any questions if you might have them.
Wonderful. Thank you so much, Lisa. While we wait for questions to come in, I know it always takes a minute or two to type them in. I have a question, and it's gonna show my ignorance and how much I still have to learn. So
Okay.
I always imagined asteroids to either be like smooth rock surface or looking like lava rock, with lots of holes in it. But I never imagined it to have that many little rocks on it, because I thought, well, there's no gravity for that. It doesn't have a core like a planet.
Mhm.
So all the little things would just fly off, like all the stones would just go. So where am
Uh,
I wrong in my thinking, Lisa?
Okay, so that is a fantastic question, and there's two ways to answer that, and one of them is that asteroids actually have turned out to be rockier on their surfaces than we expected. And what I mean by that is a little bit more jagged. Um, the rocks that you see on the surface, a lot of them are likely due to when we take a look at a asteroid from a distance, one of its most common features tends to be craters. And so when objects come in to make the craters on the asteroid, they kick up debris and that debris falls back down. These objects do have gravity, it's low gravity. So it's easier for that material to escape. Now, when that asteroid material escapes and then say it hits the earth and makes it to the ground, that's what we call a meteorite. And in fact, there are some meteorites on Earth that we can actually identify the particular asteroid that they're from. There's a large asteroid in the asteroid belt called Vesta. And we have several asteroids. We have several meteorites here on Earth that we actually know come from Vesta. And I think we even discovered a meteorite on Mars with that same chemical signature. So that already would have been. So, yeah, that's another thing. We find meteorites on the surface of Mars. So we've had rovers roving around on the surface of Mars long enough that we have actually discovered meteorites there.
That's interesting.
Yeah,
Thank you for that.
no problem.
And we do have a question coming in,
Mhm.
and I'm going to pull it over so I can read it better. How much does light pollution affect meteor showers? If I were to go to see the Gemini is, yeah,
Yep,
in
good job.
December, would I see a massively increased rate if I went to, say, Mojave Desert versus Anza Borrego?
So, when I see the Bortle 1 versus Bortle 3 there on that Bortle light pollution scale, once again, that depends on where you are because there's two things. Light pollution does make a difference. Some meteor showers do tend to produce fainter meteors overall, and other ones brighter ones. But what you need is to not have light in the part of the sky that you're looking towards. And so when we're taking, like most of the time, you want a good view, say, of the eastern part of the sky, because we tend to look for the meteor showers when the constellation is rising. So if the city of San Diego is behind you, and you have a nice dark view to the east, either way, that's fine. And so Anza Borrego has many locations inside of it that are actually International Dark Sky Association highly rated. So either one of those would be good.
Thank you so much.
You'd actually be surprised what we can see from downtown San Diego too. When there's no marine layer, you can actually see a decent amount with out the humidity, the light bouncing around with the water vapor in the atmosphere. So you just need no light towards the constellation you're looking at.
Thanks, Lisa. The next question we have is, can the impact of satellites with the comets affect their path?
So that's a really good question. The answer hypothetically is yes, because any collision should impart a little bit of momentum from the incoming object to the one that it hit. In reality, though, the comet itself is much more massive and going much faster. So it's really the bug on the windshield effect, right? The truck just keeps going. So, but you would need to actually have a much bigger impact for us to make a difference. Good
Okay.
question.
Yeah, I like that too, especially since it um, kind of plays on my nerdy side of movies. And, there's an asteroid coming towards Earth and we need to derail it. So I really like that question.
Well, no, and that's interesting too, because knocking an asteroid off course actually would be one of the best ways to try to avoid getting hit. But because our ability to do it is limited by size and speed and what we can get up to, we would need to see it really far in advance. So a little bit of a nudge would make it miss us by by a lot, as opposed to if we saw it closer, we'd have to hit it harder.
Yeah.
Nerd.
The next question is, could you tell us more about the Ceres asteroids, the biggest one in our solar system?
All right, so the asteroid Ceres is the largest asteroid in the asteroid belt. It's the largest asteroid in our solar system. So large and so close to spherical that it got put into that weird dwarf planet category that I dislike terribly. So we're just going to call it the largest asteroid in the asteroid belt, discovered in the early 1800s and visited by NASA's Dawn spacecraft. And what's really interesting about it is that some of you might remember images. There's a big region on it, or almost what looks like a big crater, and there's little bright white spots in it that um, actually are kind of like saltwater ice. It leads to the idea, and it's not a constant amount there. And so it leads to the idea that Ceres may actually be geologically active. It may have a briny saltwater ocean underneath its surface, and it gets to the surface via something that we often refer to as cryovolcanism or cold volcanoes. I love that. Cryovolcanism. I love it.
We should talk about that at one of the talks. That sounds fascinating.
I'll mark that down.
Yeah. And then we have a question. I love the bright and high contrast lighting in all the asteroid photos that you showed. Are most of them really that reflective in the close-ups?
So that's an interesting question, Peter. Hello, Peter. Not a surprise you're asking
Hi,
about a
Peter.
photography question. So they are going to be pretty bright at the distance of the spacecraft itself, because we're talking about these are spacecraft really close to the reflecting surface. And so especially at high contrast with the dark region of space around it, it doesn't take much to be the brightest object in your frame. So yeah, because it's not like we can actually send out these spacecraft don't have flashes on them, right? So these are all natural lighting. So yeah, you're seeing the high contrast, and sometimes we're just doing stacked imaging as well. But with comets, because they're moving and then the spacecraft's moving, that can actually be a little tricky to try to track. So yeah, we're just seeing high contrast lighting, like natural high contrast lighting, because you have the thing reflecting sunlight and then the darkness of space to compare it to.
Yeah, that's one thing that fascinates me when I see your pictures is, I mean, you know, space is dark, but when you see the pictures, it just hits you what
Yeah.
that really means. Like, because dark means something different for us on Earth sometimes, I think.
Right, because we're always underneath the atmosphere, and so the atmosphere is
Exactly.
always scattering some light, so the sky is always a little bright above us.
Yeah,
Yeah,
exactly. It's fascinating.
yeah.
Interesting question also. Is Mars ever going to blow up?
No, probably not. Mars doesn't really have a much geological activity left on it now, so we don't even see active volcanism on it currently, or at least not any solid evidence for active volcanism. So for it just plan on blowing up, probably not. But I still have hopes for a volcano going off.
Cool.
Yeah.
So there's no silly question. I want to preface with that because that was one of the comments in the question is, but do comets travel on their own orbit, or how is their path determined?
That is a good question, actually, because we tend to think of orbital paths as being dominated by bigger things like planets. But comets do follow their own orbital paths. And periodic comets, like the short period comets that we see coming towards us from the Kuiper belt, we see some of them multiple times, like every 33 years or every 76 years. We've seen them not just over the course of recorded history, but over the course of human lifetimes. You can see a comet multiple times. So they do have their own distinct orbit. That's true for short period comets. The long period comets, some of them actually just come in once towards the sun and fly back out on these parabolic orbits. The Oort cloud that they come from is large enough that some of these comets are coming in because they got a gravitational assist from an interaction with a nearby star, and it just kind of kicked it in towards the solar system, and it is not going to be on a regular periodic orbit. So a lot of these and also, even the ones that do, they're going to have such long orbits that they're not going to be over the course of human lifespans. But yeah, they do have their own distinct orbits.
Thank you. I did like that question a lot. How long is the lifespan of a meteor? How long does it last until it disappears?
That is a good question. When you're out looking at a meteor shower, these are really just streaks going across the sky. So if you saw that, if you remember the webcam image, that was real time, just like
Oh, wow.
yeah. So they might last a second or so as they go across the sky.
Oh, yeah.
Yeah.
Amazing. And the next question is there a possibility of discovering new elements on a comet?
That is an interesting question. The answer to that is always yes, but not likely. What we tend to find in space are the same materials that we have here on Earth, just in different forms. Like here on Earth, you and I would not find ammonia as ice, but we see it as ice in that phase in comets. There are some things here on Earth there are some chemicals bonds that don't happen here commonly on Earth that are easier to happen in space, and vice versa. Some things happen easier here on Earth because the air is denser. So the answer to that is yes, but so far we have never discovered anything out in space that we haven't been able to make here or discover here on Earth. It's just, yeah. We found iron in the atmosphere of the sun, but it was so hot it stripped off like half of its electrons. So we'd never seen it in that phase here on Earth. And so we had to understand the structure of the atom before we could understand what we were seeing in that chemical spectrum. So it's sort of it's a game almost. Did we find it here on
Yeah.
Earth first or did we find it elsewhere first? And remember, helium we found in the spectrum of the sun first. That's why it's named helium after the Greek god of the sun. We found helium in the sun about 30 years before we discovered it here on Earth.
Oh, wow.
Yeah.
I did not know that either. The things I learn at our events is amazing. I'm going to take a question from Susie. Hi, Susie. Have the planets changed their orbits and or their distance from the sun?
I love that question because if you had taken Astro 101 with me a very long time ago, at this point, the answer would have been no. And now the answer is yes. We do see evidence that planets migrate in their orbits. That's the term we use as planetary migration. Um, we started to really have to think about it when we started finding planets around other stars. And you might have heard the phrase hot Jupiter, that we find these really big planets, but really close to their stars. And that isn't what we would have expected from our solar system. And so it brought up the idea of, do planets migrate in their orbits at some point after their formation? In our own solar system, in order to get that Kuiper belt, that sort of ring of icy objects that are all pretty much outside the orbit of Neptune, that was likely due to gravitational interaction between those ice balls and Jupiter, Saturn, Uranus, and Neptune, because you can really start to make lots of ices out at the orbit of Jupiter because you're further away from the sun, so it's colder. So what we think probably happened is that through gravitational interaction with those planets, it gave kicks to the ice balls, which is why they're in the outer part of the solar system. But things like conservation of angular momentum and stuff caused the orbits of the planets to get wider spaced. So we do actually think Jupiter, Saturn, Uranus, and Neptune also all used to be closer to each other and closer to the sun, and that Uranus and Neptune in particular are more spaced out than they used to be. So planetary migration is the term you're looking for.
All right. Planetary migration. You're taking that away from tonight. There's so many great questions.
There are.
How is Betelgeuse doing? At the beginning of the year, it was on watch for possibly blowing up. Is that still going to happen sometime soon?
We can only hope. Betelgeuse had returned to its usual brightness, which was one of the many disappointments of 2020. But when you take a look at its average brightness now, it's actually below its average brightness again. So keep your fingers crossed for this winter. But Betelgeuse is known to have some variability in its brightness. It is a red supergiant, and so it can go through phases where there's more flares, or what is likely in this case was a production of dust in the outer layers of the star, is what the current thinking is of what caused that dimming. So we have a lot to learn about what's going on with Betelgeuse. And like I said, I personally am hoping it explodes. I would like to see a supernova that would be that bright in our sky. But yet also at a safe distance for the Earth. But right now, Betelgeuse is still behaving weirdly, but not as weirdly as it was early last winter. Great
Thank you.
question.
Is there a bigger star than the sun?
Yes, the sun is a fairly typical star. There are stars larger, stars smaller, stars hotter, stars cooler. It is a very I like to think of it's a very typical star, which makes it a good laboratory for us to study.
Very good. And if we wanted to watch the meteor shower on November 17th at 3 o'clock in the morning, where in San Diego would it best to see?
So, good question. What you want is an unobstructed view of the eastern part of the skies. So you just want to be able to look east, have sort of a big view. So, if you are, if you live in an apartment in a tall building and you've got nothing to your east blocking your view, that's fine. I tend to think of meteor showers. You want a relatively dark sky if you can. But
Mhm.
these are also things where when the meteors are bright enough, you can see the brightest ones from a city. You might not see all of them, but you can still see some of them. So if you've got good weather and a place to go where it's nice and dark, go for it. But otherwise, just try it at home.
That's what I'll probably do.
Yeah.
'Cause otherwise I have to get up even earlier to go somewhere, which is probably not going to happen.
Yeah. Well, like I said, the one time I did, we went out into the middle of the desert for the last Leonid meteor storm,
Yeah,
and that was worth it. That was
I
worth
bet.
it making that effort because it did look like there were fireworks going off for about an hour.
Yeah, in 2032, I will consider that for sure because I've never seen anything
Absolutely.
like it. So yes,
Absolutely. You
I
just
would.
get your hot chocolate and you go to the desert and you watch it.
Yeah,
Yep.
that's what I would do for sure.
Yeah.
So I know we're a little bit over time.
Okay.
I'm happy to keep going.
I can keep
Lisa,
going.
how are you? Are you also good? Go.
Yep.
Let's keep going. Let's answer those questions.
Yes.
Can comets orbit a planet rather than the sun? Oh, I forgot to put up the poll. Sorry, I do have to interrupt real quick because before people start leaving now because we're over time, I'm going to put up the poll real quick. We always love to hear about our audience and why you come, what you enjoyed, if you enjoyed it. So if you could take that survey, that poll real quick for us, that would really help us out quite a bit. Now we go back to the question. Can comets orbit a planet instead of the sun?
I love that question. If they did, we wouldn't call them a comet anymore. We'd call them a moon, and they wouldn't be getting significantly closer or further away from the sun, so they wouldn't be developing tails anymore. They just look like a chunk of ice, a weird shaped chunk of ice orbiting a planet, which basically defines most of the moons that orbit Jupiter, Saturn, Uranus, and Neptune. And so when we take a look at some of them, they do look like captured asteroids, or perhaps if they're icier than others, maybe even captured cometary bodies. That's totally possible. Yeah.
Interesting. Thank you. Thanks for that question.
Yeah, great question.
Also, good question. What happens with the leftover materials of the meteor shower?
All right. So we plow through that material, but we don't sweep it all up. Think of it like, when you're dusting, there's always something you leave behind,
Yeah.
right? And so we plow through some of that material, but we don't go through all of it. So that's why there's still stuff to run into every year. Over time, will it eventually get swept up or will it eventually just kind of break away? That is possible. But right now, it's just going to follow the orbital path of the comet because basically it's still just trying to stick, it still thinks it's a comet, right? So
Yeah,
it's still trying to orbit the sun in that same orbit.
got it. So until we get Mel Brooks's space vacuum.
Yeah. Yeah, we
Okay.
got time. We got time.
Okay, good. um, you can see I'm a little bit of a movie nerd. Interstellar asteroid Oumuamua, sorry if I messed that up,
That's not bad.
appeared to be under slight acceleration on outward journey from the sun. Are there any updates on this?
So, interesting question. That was that, like in the last couple of years, we've had two what have been referred to as interstellar visitors, two objects coming through our solar system that looked like they came from outside the solar system. And Oumuamua was one of them. And it's too small. We can't see it anymore. So I can't really answer your question, but it is definitely one of those objects that just came through once and we're not going to see it again.
Hmm. It's
Yeah.
interesting to think of
Yeah.
them as interstellar visitors, right?
Yes, they are interstellar
Unfortunately.
visitors. Yeah.
Yeah. So if the answer to the next question is yes, Lisa, then I will sign up for the next mission out there. The question is, on Mars, does it rain diamonds?
No, I'm sorry, it does not rain diamonds on Mars. However, in some meteorites, you find tiny little micro diamonds, what we call micro diamonds. They're really, 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 really tiny, though, just like little bits of diamond dust. And the cores are basically what we call white dwarfs, which are the leftover cores of low mass stars like the sun. They are mostly made out of carbon, forged at high pressures and high temperatures. And sometimes when we take a look at their chemical signatures and their spectra, they look kind of crystalline. So there are diamonds out in space, but the Martian atmosphere, Mars does not have the sort of pressure and temperature that you would need. But yeah, no raining diamonds on Mars. Sorry.
That's okay. Right now, there's only one-way trips to Mars, and so
Very true.
and I don't have to go for the diamonds.
Yes.
Thank you for that question and for the answer. I appreciate it. You mentioned earlier that helium was discovered on the sun first before we discovered it on us, but how did we discover it on the sun first?
Good question. So, you know how when sunlight passes through a prism, it breaks up into all the colors of the rainbows? Well, if we break it up through something called a spectrograph, we can tell that there are chemical signatures of the elements in that light. It carries what we call spectra, particularly absorption spectra. And so we can identify that the spectra of a chemical element or of a molecule is basically like a fingerprint for that. It can be uniquely characterized by this pattern of light that we see. And so when we were looking at the light from the sun, hydrogen was the most prominent, and then we found a couple of elements, but there was sort of like um, a pattern of lines left behind that we couldn't match up to anything. And so it was named, oh, it must be a new element. So we'll call it helium after Helios. And then we eventually discovered by doing experimentation here on Earth, helium here on Earth. It's like, oh, look, that chemical signature matches. And this has happened multiple times in astronomy. There was an element named nebulium because we saw it in the light from nebulae, but it turns out to be oxygen, just such a rare form of oxygen that it can only occur in the incredibly low densities of space, whereas here on Earth you wouldn't see oxygen like that. So yeah, but yeah, it's looking at the chemical spectra of the light. That's how we identified helium on the sun.
Interesting. All right. Can I see the Perseus constellation?
So the Perseids come from the constellation Perseus, and that is up in the sky tonight, up in the northern part of the sky. Perseus was the hero that saved Andromeda. So look up in the northern part of the sky to find Perseus.
Northern part.
Yep.
And next question, what scale did you mention indicates the light pollution? Oh yeah, that the little
There's something called a Bortle scale that is used to rank. I can never see it without thinking of The Good Place at this point, but it ranks light pollution by you take a look at what are the faintest objects that you can see up in the sky. So it lists. So it's the Bortle scale.
Yeah, I was wondering about that word earlier. Thank you. Thanks for asking that question. Next question is a little bit outside what we've been talking about, but still very interesting. What's the name of the biggest black hole? And do we name black holes?
We tend to name the biggest black holes. Well, let's put it this way. The biggest black holes that we see are supermassive black holes at the centers of galaxies. And so they tend to be named after the galaxy that they're in. So for example, one that I can think of that's really huge would be the one in the middle of the giant elliptical galaxy called M87, which is the one that you might remember a couple of years ago, we finally imaged the event horizon, well, not the event horizon, but the size of a black hole. It was that one because it's so huge. It's actually easier to photograph that one than say the supermassive black hole in the Andromeda galaxy next door. So that would be one of the biggest ones that I can think of. But they tend to be named after the galaxy that they are nested in.
Which makes sense.
Yeah.
Then you know where they are.
Yes.
This is kind of off topic, but what is your view on extraterrestrial life? Is there a chance we can find it in the future?
All right. So extraterrestrial life, it should be common. if you take a look at the chemical elements that make up you and me and the other stuff here on Earth, those materials that we are made of are some of the most, if we ignore the hydrogen and helium, life is made out of the most common elements in the universe, right? Hydrogen and helium make up most of the universe. Of what's left, a lot of that makes up us. So if I were to give a biologist, an evolutionary biologist or any biologist, the elements out in space and the molecules we see out in space, and if I were to ask them, can you make life out of this? Their answer would be yes. And so the question is whether or not you have the correct conditions and the solvents like water and all those other things. But it would surprise me if life wasn't abundant in the universe. Um, why haven't we seen evidence of any like hard evidence of any other? Space is big and we are small. If there was only one planet with life on it in each galaxy, there would still be billions of planets with life in it in the universe.
Yeah, but it will be hard to get to because we're so far.
Or to even notice. Yep, because space is so big.
Yeah, thank you. Ooh, that would make another good movie. Can a sizable comet punch through a gas giant's planet's atmosphere, coming out again on the other side if it doesn't hit it straight on?
All right, so the comet, we've seen comets run into Jupiter. The first one was Comet Shoemaker-Levy 9, where it broke apart and came in and hit it in different pieces. And so we got to see these little puncture wounds on Jupiter. The likelihood, though, of its surviving going through an atmosphere, right? You can either talk about it skipping off, like trying to skip rocks, but if it entered a gas giant's atmosphere, the temperature and density increase fairly rapidly. And so it's more likely to break up the comet and not have it be able to survive intact going through. That would be more likely for an asteroid, which would be a hardier material. But even then, we've seen asteroid impacts on Jupiter now, and it just tends to just go in. So I think, the question is if it just stays like at the most least dense part of the atmosphere, could it come through? And then the answer is going to be hypothetically yes, but practically that's such a narrow range of possibility that not very likely.
Thank you. How complicated is it to calculate the period of comets? Can that be done with Kepler's laws or equation, or does that require more modern mathematics?
Kepler's laws tends to be good enough. It's just when you get to the orbits that are more parabolic instead of elliptical, right? Were the ones that are going to come in and get cut off, and then they might be affected by the gravity of the sun. The orbits itself can change when it gets close to the sun, especially for those a long period comets. But Kepler's three laws of planetary motion were basically Kepler figuring out the laws of gravity before Newton. Newton used Kepler's work to help figure out the law of gravity. And so Kepler's laws work. Do they need tweaking? That's usually more dependent on the type of the comet or if the comet gets nudged in its orbit by the sun. But yeah, otherwise Kepler works.
Perfect. So we have two more questions, then Lisa, I will let you go. I don't want to take up all your evening time.
It is very nice to answer so many questions about science right now. I'll just say
okay,
that.
good. Yay. We love it. Yeah.
Yes.
I love thinking about the beautiful sky tonight.
Yes.
Are there colors on Earth different than in space, or are there colors that we can find on Earth but not in space, or vice versa?
So that's really an interesting question because part of it depends on how you define color. The colors that you can see with your eye are based on what the goo in your eyes are sensitive to. I am not an anatomist. I cannot answer anything about the eye, but there is a very narrow range of wavelengths that the human eye is sensitive to. And that makes up the colors of the rainbow. There are other wavelengths of light that we can't see with the eye, like X-rays and ultraviolet and radio waves and infrared. We don't see those with the eye. And those do exist out in space. But colors, the colors are actually more difficult for us to see in space because the pretty pictures of nebulae that you see require hours usually of exposure time by a camera because they're so low density, they don't emit a whole lot of light. And you and I could be looking right at one and that wouldn't get enough light to trigger our color receptors.
Got it.
And so it might just look a little ghostly gray. Like if you take a look at the Orion Nebula through binoculars, even though it should look kind of reddish, it only looks gray because even with binoculars, we're not getting enough light to really trigger our color receptors in our eyes. So a lot of that is human eye based, not so much space based.
So if we could engineer something that is close to the human eye, but has a different sensitivity that could capture those colors for us, then we
Yeah.
might be able
I mean,
to
the
see
image that
what
the
color.
image that behind me is right now is a Spitzer Space Telescope image of a galaxy, and that's an infrared image. And so it is basically looking at that galaxy in the infrared, but then color coding it
Yes,
so that we can see it with the eyes. Yeah.
exactly. Yeah, perfect.
Yep.
All right, that brings us to the last question of tonight is, can comets run out of material?
Absolutely. Yes. Comets should have lifespans. They lose material every time they get close to the sun. And so every time they start chunking stuff off, that stuff, they don't gain that anywhere else. And so, yes, comets should have lifetimes then. Great question.
Do we know a life? I mean, depending on size, right? But
It's going to depend on size and how often they orbit the sun. So a comet like Halley that orbits once every 76 years is going to have a shorter lifespan than a comet that orbits once every 10,000 years. And so
yeah.
there's a lot of factors to it.
Do we know when the Halley's Comet is going to be done? Could we calculate that? We
You
know
can
its mass. We know how
you,
often it.
yeah, you could make estimations of that. I can't think of a number off the top of my head, but that's definitely a calculation you could attempt based on how much mass we see it losing when it's close to the sun. Absolutely.
Great. Well, there you got your homework to do for
I was
next
just I
guy
was just
tonight
thinking
when you
that
join us
homework.
for the next one. Lisa, thank you so very much for
Thank you.
joining us tonight, for hosting Sky Tonight virtually. Really appreciate your time and expertise.
Thank you so much for having me. It's great to be here.
And thank you, dear audience, for joining us tonight. We wouldn't do
you.
it if it wasn't for you showing interest, for you being here, still loving science despite the virtual worlds, and still being curious, still wanting to learn. So thank you so much for being here and joining us tonight. And we'll see you again next month when we talk about galaxies.
Yes, absolutely. Looking forward to it.
Perfect.
Bye-bye.
Thank you all. Bye. Have a great night.